Hello, my name is Jared Schmal. I'm the sales manager for Microflown Technologies, and today we're going to be looking at our Scan and Paint 3D solution. So how to set up the equipment and to utilize the solution for your acoustic needs. So Scan and Paint 3D is a great kit. All the hardware is located in this Peli case, and it's a great kit for being able to complete full 3D visualization of your acoustic sources as well as their behavior. So looking at directionality as well as those directivity paths of the acoustic field itself. So let's look at the equipment here. So the core of our technology is our probes. These contain particle velocity transducers as well as sound pressure microphones. And with that, we can capture sound intensity directly by multiplying particle velocity by sound pressure, therefore obtaining the entire acoustic field. So this is a standard 1/2-inch form factor where we have a 4-channel solution here, 3 particle velocity transducers here in the tip, as well as sound pressure. So particle velocity at the X, Y, and Z direction. And with that, we need to connect it to our data acquisition system. Here we have the Microflown Voyager. The Microflown Voyager is a vibroacoustic analyzer. It can be used for both. So it's great for in the field for being able to hear your acoustic sources as well as quickly connect it as a data acquisition unit. So let's connect these together. So that's how we collect the acoustic data for Scan and Paint 3D, but we also need to track the location. And usually we need to do that very accurately. So we need an accurate system to be able to collect the coordinate positions of the probe as we scan across the surface. For that, we use a PST iris camera. This is a stereo camera that collects infrared signals, and it's tracked using this optical tracking sphere. This has randomly spaced reflectors located around the sphere that allow us to track it with high precision, down to 3 millimeters. We connect all of that to the remote handle. This allows a single operator to be able to control the measurements entirely by himself. We just connect the remote handle to the tracking sphere, connect the LEMO connector to the back of the tracking sphere, and then connect the probe to the front. Turn it until you can feel it snap into the tracking sphere. All right, now we have the system set up. So we have our acoustic sensor located at the end of the tracking sphere. It's ready to go, connected through the LEMO cable to the Voyager data acquisition unit, and now that is plugged into the laptop via USB. The tracking system is also all ready to go. We have it set up on the tripod, pointed at the source that we're going to measure, so it can track through this optical tracking sphere as we move the probe along the measurement area. This tracking sphere can measure within a volume, tracking 6 degrees of freedom down to 3 millimeter precision. So no matter how we move the transducer, as long as it's within line of sight to the PST iris, it will track the location with high accuracy. We go to our software to now set up the measurement equipment. So within the Velo software, which we use for Scan and Paint 3D, we have 4 tabs. The first is the Hardware Setup tab. In the Hardware Setup tab, we have to set up our data acquisition unit, which is automatically detected whenever we plug it into the computer. We activate the remote handle by clicking the trigger button on the back. That turns on the power to the remote handle, and then we enable the remote handle in the software and see that it is connected to the system. Next, we go to the 3D Tracker tab. This is where we set up the PST iris camera. Initially, we need to load a calibration file, but once that's done, then we can go ahead and locate the position of the camera to make sure the optical tracking sphere is viewable in both camera views. We can then change the exposure of the camera depending on your infrared location. So this depends on the amount of light you have in the room or the sunlight coming through the windows. Next, we need to make sure that the correct calibration coefficients are installed in the software. We can add a calibration for the probe you're using by clicking Add. Then a calibration file can immediately be loaded into the system. This, just like the calibration for the PST iris, only needs to be done once. We click the Auto Set Channels here to distribute the correct channels throughout the probe. Now that we see green, our probe is ready to be used. The next tab is the Measurement Setup tab. This is where we import our CAD model and define our 3D field of view. We go to the Import folder and load our CAD model into the system. Now we've loaded a CAD model into the software. I used a .object file, but you can also use other standard file formats such as .stl. These can be easily exported from your CAD data that you have, or you can easily scan the object with an iPhone Pro or an iPad Pro. There's a free app that can be used to quickly generate the CAD. Next, we need to calibrate the position of the camera relative to the source. We do that through a quick calibration step. We click on the Locate 3D Tracker button and a window opens. Now we need to select 5 different points on the CAD model. These should be as diverse as possible and not all on the same plane. Now we place the tip at the location that we defined in the software and press the trigger button on the remote. And we do that for all 5 locations. So now we can see that the camera has adjusted itself to the correct position relative to the source. We then replace the tracker with the 3D probe. Now the setup is complete on the Measurement Setup tab, and we'll move on to the Capture tab. Here we can see the real-time spectrum of the probe. We can whistle to make sure everything's working correctly. We see that the sensor recognizes the acoustic sound. We then need to set up our DAC sensitivity. This is dependent on the source. So now we turn on our source and we can start the captures. We can capture as many times as we want so that we get full resolution of the source itself. We can also move the camera as many times as we want if you have large or complex objects to be able to scan around the full source. Just remember, if you move the camera or the source itself, you have to recalibrate the camera's position. So now let's perform a measurement. We can see it starts a measurement in the software. When we're ready to scan, we just click and hold the trigger button on the back of the remote handle. So we turn on our sources. Okay. With the source on, and then the optical tracking sphere in line of sight with the camera, we can complete the measurement. We see that the capture has started in the software. We press and hold the trigger button on the remote while we're performing the scanning measurements. So once you have scanned your object to your satisfaction, then we can move on to the Processing tab. And now we need to generate a new process. We right-click on the Processes button in the Processes tree. We go up to the top to click on Project, Processes, 3D Cuboid. A new window will open that lets us define our settings for that process. All the measurements are automatically encompassed by a cuboid grid. This grid breaks up the time series signal to be able to calculate the FFT points for the acoustic results. We can define our spatial resolution by changing the size of each cuboid. You can see that the cuboid is automatically adjusted. We can then select which captures we would like to use for the process, as well as our FFT settings. Once done, click Start Process. Now we can see the acoustic results of the object under test. So not just the magnitude, but also the 3D vectors. We can do frequency analysis by clicking and sliding across the frequency spectrum, as well as look at many different acoustic variables, including particle velocity, sound intensity, sound pressure, coherence, animated phase. And there's many tools to help you visualize your acoustic data and analyze it to understand the acoustic field. So that's how you set up and perform a measurement with the Microflown Scan and Paint 3D solution.